Hello everyone. In this video, I will be talking about motion in a plane. In motion in a plane, the first part is vectors. We can see about vectors. A vector quantity is a quantity that has both a magnitude and a direction and obeys the triangle law of addition or equivalently the parallelogram law of addition. That is, a vector quantity has got magnitude and direction. A vector is specified by giving its magnitude by a number and its direction. A vector is often represented by an arrow placed over a letter as shown. Here, a vector is shown. That is, here V, there is an arrow on top of it. Some physical quantities that are represented by vectors are displacement, velocity, acceleration, and force. Now, position and displacement vector. Position vector is a straight line having one end fixed to a body and the other end attached to a moving point and used to describe the position of the point relative to the body. As the point moves, the position vector will change the length or in direction or in both length and direction. Here in this figure, let us consider O as the reference point and A is the first position of the body. So, the position vector with respect to OA, which has a magnitude of R1. Now, after a time t, the position changes from point A to point B. Then the vector is given by OB having a magnitude of R2. The vector AB is known as the displacement vector since it gives a displacement between the initial and final positions. A displacement vector is a straight line joining the initial and final position and does not depend on the actual path undertaken by the object between the two positions. The magnitude of displacement is either less or equal to the path length of an object between 2 points. Now, addition of vectors. These are some properties of addition of vectors. That is, it is commutative. That is, A plus B is equal to B plus A. It is associative. That is, A plus B plus C is equal to A plus B plus C. The result of adding two equal and opposite vectors is a null or zero vector. That is, A plus minus A is equal to 0. And if we add 0 or a null vector to a vector, we get the same vector. That is, A plus 0 is equal to A. Now, we can see the graphical addition of vectors A and B by using triangle law. Here, A is the shown by OP. Now, B, vector B is shown by PQ and it is kept to the end of A at OP. Now, the resultant vector is given by OQ. That is, A plus B is given by the vector OQ. This is the triangle method of addition. Next, we can see the parallelogram law of addition. In this case also, OP is the vector A and OQ gives the vector B. Now, these two vectors form two sides of a parallelogram. Then, the resultant vector of vector A and B is given by the diagonal of this parallelogram. That is, resultant vector R is equal to A plus B. This is the parallelogram law of addition of vectors. Now, resolution of vectors. The process of splitting a vector is called resolution of vector. The parts obtained after splitting the vector is called components of the vector. A given vector can be resolved into two component vectors along a set of two vectors and all the three lie in the same plane. Here, we can resolve a vector A into two other vectors, which are lambda A and the other one is mu B. By triangle law of addition, here lambda A plus mu B is equal to A. But it is more convenient to resolve a general vector along the axis of a rectangular coordinate system using vectors of unit magnitude called unit vectors. Here, in the first figure, it shows the unit vectors along x direction, y direction and z direction. Along x direction, it is I cap. Along y direction, it is j cap. And along z direction is k cap. Now we can resolve a vector A in the y-x plane. And this A is resolved as ayj cap, which is along the y-axis, and ax I cap, which is along the x-axis. From this, we can see that A, which is the total magnitude of vector, is given by root of ax square plus ay square. And the angle theta, which the vector makes with the x-axis, is given by tan inverse of ay by ax. Now addition of vectors by components. This is a more accurate method of addition of vectors compared to the graphical method. In this case, consider two vectors, that is A and B. A is equal to ax I cap plus ay j cap plus az k cap, and B is equal to bx I cap plus by j cap plus bz k cap. On adding all these components along the various unit vectors, we get the resultant vector R, which is R is equal to Rxi cap, where Rx is equal to Ax plus Bx, Ry is equal to Ay plus By, and Rz is equal to Az plus Bz. So this is the end of this slideshow. In this video, what I have described is some basic concepts regarding vectors and vector addition. This can be further applied in explaining the concepts of motion in a plane. If you have got any doubts in any of the topics discussed in this video, please comment in the section below this video. Thank you.